Okay, so today's notes, we are going to have information on a graph, and then we're going to come up with the equation for the graph. Equation for that absolute value function that is being graphed. So there's the first problem. Okay, so we are finding the equation of a absolute value function, and we're going to start with this, our general form for the absolute value of a function, of the equation of an absolute value function. So it is y equals a absolute value 1 over b x minus h plus k. Remember that formula from yesterday, that equation from yesterday. We talked about what A and B represented. We talked about H and K. H and K tell us the vertex. And then A and B are vertical and horizontal compressions or shrinks. Okay, so in order to find the equation of an absolute value function graph, we have to let A or B equal 1 in order for us to find it. And actually, so in this case, we're going to let B equal 1, and then plug in what we know to find the A value. So we know the vertex. What is the vertex? 1, 6. So this point right here is the vertex. And then we have a point that it goes through, except I'm going to write that in a different color. We have the point 0, 3 that it goes through. So though we're going to use those. You have to know of the vertex. You have to know one point on the absolute value line graph. So we're going to plug those values in. Our vertex we can put in right here. It's going to be, is it going to be x minus 1 or x plus 1? Minus 1 because it's actually to the right. So we're going to go minus 1. And then the 6 is the k value, so we can put plus 6 out here. We said we were given that b equals 1, so 1 over 1 is just 1. We're not going to put anything there. We're trying to find a. So on that first step, we have plugged in our vertex, correct? Step 2, now we're going to use one of the given point that we have and use that for x and y in the remaining equation that we have. So where I see this y, I'm going to put the y value of the point that is not on our vertex, not the vertex. And then where I see x, I'm going to put the x value of the extra point that we found. And then I simplify. 0 minus 1 is a negative 1. And then we're going to take the absolute value of that, which is just going to be 1. So we get 3 equals a plus 6. I'm going to write that over here because I ran out of room. And then solving for a, you just subtract 6 from both sides. So we get a equals a negative 3. So we're going to go back into the equation of our absolute value function. We're going to plug in a value for h, a value for k, this value for b, which we already know is 1, and then what we just found for a. X and y we'll leave alone. So I got to erase all this, sorry. And so my function is y equals, we said a was a negative 3. 1 over b, b is 1, 1 over 1 is 1. We don't need to mess with that. We're going to plug in our h and k, which is our vertex, so x minus 1 plus 6. And then the only thing we need to change is write it as in function notation. So f of x equals -3 times the absolute value of x minus 1 plus 6. And that is the equation for the function that is graphed. So let's state the domain and range. Absolute value domain is always negative infinity to positive infinity. Unless they give us a restricted domain, your absolute value domain is going to be negative infinity to positive infinity. And then our range, remember I said your range is determined by your vertex. So it's either going to be the y-coordinate. So it's either going to be 6 to positive infinity or negative infinity to 6. Because it opens down, it's all the values less than 6. So our range is going to be negative infinity to 6. All right, so our second graph, we know a equals 1. The vertex is at -5, -1, and it goes through the point, one of the points it goes through that we've identified is -3, 3. So we have our vertex, -5, -1, and a point that it goes through is -3, 3. We're going to use that information to help us find, and also that a equals 1. So first step, I'm going to plug in for my vertex. So, whoops, I forgot my absolute value right here. Missing that second half. Everything else look good? Okay. So first step, I'm going to plug in my vertex. So I have y equals a 1 over b. And how am I going to write my vertex? It's -5, -1. So Cheyenne, what does that mean? Is it going to be x plus 5 or x minus 5 in parentheses? X plus 5. Now outside of the parentheses, am I going to use -1 or +1? -1. Okay, so we plugged in for our vertex. And here's a point that's on our graph, so we're going to use the -3 for the x and the positive 3 for the y here. And then we're also going to say that a is 1. So the only unknown is going to be b after this point. So y is 3, a is 1, so we have 1 over b. Oh, x is, we said -3. So there's our equation. And simplifying, we have 3 equals absolute value of 1 over b. -3 plus 5 is 2. Minus 1. And then if I add 1 to both sides, I get 4 equals the absolute value of 1 over b times 2. So 2 times what gives me 4? 2. So 1 over b has to equal either 2 or a -2. Because our graph is opening up, we're going to go with 2. Okay? So 1 over b equals 2. Well, I think we'd have to have it, a would have to be a -1. We're just going to go with the positive value here. Okay? Because we have that plus 5 in there, so it could change. All right, so now we're ready to rewrite this equation, and we're only going to plug in for h, k, a, and b. We're going to leave x and y alone as variables. so our equation is going to be y equals, we know a is 1, so I don't need to put anything there. 1 over b we determined was 2. X minus h, which is 5, but we're going to make it plus 5 because it's to the left, and that's the opposite. And then k was down 1 or negative 1. Final step is change that y to f of x. So page 54 are 5, and then 11 through 13 and 18. 5 and 11 are graphs like yesterday. The instructions for 5, I don't want you to follow. I want you to follow what you did yesterday, where you found the vertex, another point, you graphed it, and stayed the domain and range. So 5 and 11 instructions. For number 5, use the instructions for number 11, what you did yesterday. 12 and 13 are problems like what we talked about today. And then 18 is matching graphs with equations. So the only work you have to do there is maybe mentally what's the vertex and is it opening up or down or that sort of thing. Okay, so I'll hand out graph paper and you are ready to go.